Hey, I know it's been a while. It's quite windy out here, so hopefully the audio is okay. I know it's been a very long time. Things have just been going through the roof recently in my personal life and as well as business life. But you don't care about that. You're here for Mathematica advice. So in this video, it's a very long video, I'm going to try and go through as much as possible on how to get up to speed with Mathematica. So this is meant for beginners, if you have absolutely no idea how to even start with Mathematica, as well as some intermediary players in the game who've used Mathematica for a couple months beforehand, before even getting into a selected school that uses Mathematica. The first thing I want you to understand is that a lot of companies in Victoria especially don't actually talk about how to use Mathematica properly. They just give students a bunch of copy-pastable code, and the kids have absolutely no idea what's happening with it. They don't know how to actually use the tool. They don't know how to modify the code. They don't even understand why they're doing certain steps they're doing. And when they get an error, they get very stuck and lost. And schools that use Mathematica actually recognize this, and they're purposely making some of the practice questions and exam style questions a little bit more mathematically in depth, so that they call out and catch out these students who have absolutely no idea how to actually use the software. So it's unbelievably important, and it's really crucial that you do understand how to use Mathematica, because if you don't, you're really going to be behind the ball game. From my understanding, there's only a handful of schools in the entire state that uses Mathematica. You're not going to be following the typical CAS mathematical methods or specialist mathematics course. Instead, you're going to be following something called the CBE, computer-based examination. And this means that you are actually allowed to use a computer in your final exam. And when I did my final exam, I did the CBE syllabus as well, and we literally had laptops up in front of us whilst we were doing the math methods and specialist mathematics exams. I didn't do it further, but you know, I did both the other ones, and it was very strange because everyone pretty much had code all up and ready to go. Now, let's just get this out of the way. A lot of students to begin with will absolutely hate Mathematica. I know for a fact when I started, I was like, why can't we use the CAS? Why can't we use the CAS? The CAS is so much easier. The CAS is what I learned for years in my school. You know, everyone kind of goes through this little journey of hating Mathematica. Unfortunately, that journey doesn't really stop at the first year. So usually it continues on to methods 1, 2, or year 11, and then methods 3, 4 if you decide to continue. But Mathematica is actually a very important tool in the STEM field. I know for a fact that a lot of my engineering friends from university, they use Mathematica quite a lot. And even in some math courses in university, especially at Monash, there's actually a specific unit that goes through Mathematica in depth and expects you to use Mathematica as a tool to submit your assignments and actually do the exam. So Mathematica is a very, very important tool to learn how to use, especially if you're interested in STEM. It is a big learning curve. I'm not going to take that away. It's a huge learning curve. If you were to plot out the ease of use for Mathematica compared to a typical CAS like the TI Inspire or the ClassPad, Mathematica is very much like a steep incline. And then it's even steeper once you actually learn how to use the software to a much more advanced level. And I'll be honest, a lot of students just never get to that advanced level, and it really shows. In my opinion, I don't think VCAS should allow Mathematica to be used. I think it's incredibly stupid that they're still allowing Mathematica to be used, because it makes the typical CAS exam unbelievably trivial. And for the last couple of years, the CBE exam and the CAS exam have actually been very similar. They've been almost identical. So it's a very unfair advantage in my opinion. I don't think that schools should use it. But what's interesting is that if you look at the statistics of schools that use Mathematica or students that use Mathematica, their median study score is actually a lot lower. And I was wondering as to why that is. And it turns out, my hypothesis anyway, is that a lot of these students go to companies that are massive companies. I'm not going to name any names, but these companies give these students a giant workbook of something I call nuclear code, which is incredibly overkill code that students can copy paste without actually knowing how to use it at all. And they get answers, they get outputs. And that seems great. It's like, oh, I don't even need to know how to use it. I can just copy paste the code, change some values, and then hope for the best. But the issue is, the methods exam really tests your understanding of mathematics. And that means it also tests your understanding of the software you're using. There are numerous cases and instances where in the CAS exam, the calculators literally will not be able to solve it if you just blindly copy paste the equations. There's numerous instances of this. And you actually need to use your own logic to be able to determine, okay, well, I can take this part, do this manipulation, I can take that output and then put that into here, and then I'll be able to work a little bit more easily with the systems of equations that I'm given. And unfortunately, a lot of students that go to these giant companies that just feed them nuclear code don't really understand how to do all that because they never actually learned how to use the software. So my goal by the end of this video, and in my workshop, by the way, that's completely free, is to make sure that you are not like those other students, that you actually understand how to use this incredible, incredible tool and are able to use it well and understand what's happening. So, rant out of the way, let's jump into it. The first thing you want to do when you boot up Mathematica is, one, make sure you actually installed the thing, and two, make sure you actually put in your product key and stuff like that. Usually you've been given this through schools. I had to pay $400 for my license, so hopefully this video doesn't flop, and hopefully you find value out of it. But I had to buy a license and I had to install the whole product and software. I think I'm using Mathematica version 13.2 or 13.4. Nope, never mind, 13.1. Okay. If you have a newer version of this, you're more than welcome to use that version, but you don't actually need to use that version at all. It's just stock standard, right? So first thing you're going to see is a screen like this. It might give you a cool little animation, cool little window, but this is the first screen you're going to see. And this seems very overwhelming to begin with. To be honest, you don't need to worry about documentation. You don't need to worry about Wolfram Community, and you don't need to worry about resources. You don't need to worry about pretty much any of this junk because you're not really going to use it. A lot of the time, if you really need to use Mathematica, you'll most likely be given a file for an exam, or you need to make your own files and save them. So all you're really going to worry about is this giant button that says New Document. And if you have previous files, you can find them here. And they're all the way through, and you can find them as is, right? So you can find recent files on the side. If you've used Mathematica before, you'll probably have a bunch of them, but if you haven't, then you won't have any. So I'm just going to assume that you're ready to go. A lot of people get confused when they see the sign in to access Wolfram Cloud services because they think, oh my God, is this how I sign up and put my product key? But I did my product key stuff before. What do I do? Don't worry about this either. You don't need this. This is just completely optional. Mathematica is now on your computer if you see this window, and you don't really need to worry about any of the fancy stuff in there. If you want, you can do your own research into Wolfram Cloud. It's very, very cool, to be honest, but I wouldn't bother. It's not really needed for the things you're going to be doing. Click New Document. You're going to end up with something that looks a little bit like this. This is your first Mathematica notebook. Congratulations if you've gone this far. I know we've just clicked a button, but this is really the first step in understanding how this incredible software works. So I'm just going to take you through some of the UI, and I am using a MacBook. If you do have a Windows, it might look a little bit different, but all of the stuff should be roughly the same and in the same spots. So for example, the Windows people will have a little bar at the top that says file and stuff like that. In Mac, it's literally right at the top toolbox because that's how the Mac OS system works. I'm not sure how Linux works because I've never really worked with a Linux computer, but I'm assuming if you work with a Linux computer, you're probably okay and you're not watching this video. Because, you know, people who use Linux are usually much more technologically adept. is the easiest way to say it. Whilst I'm quite a plebeian, I don't really know how to use technology. Anyway, what you can do is you can actually click File, and you can look through all these little things. If you need to open a specific folder, you can go through and open any specific notebook that you want. If you want to open a specific file, you can click this button and it pulls up all your files in the folder, and you can click and choose just like that. We're not going to worry about any of that to begin with. Your school or provider might actually get you to change up the way Mathematica looks. I'll be honest, I'm not going to do that just because I want this to be really stock standard and really simple for you to follow. And so I'm just going to leave it as the default, but you can import and change up the way Mathematica looks very easily. School will probably tell you how to do that, but I'm not going to bother because I just don't really see the need for it. And most instances, it won't default to that color palette anyway. So you're going to have to change it every single time. I just don't really care. So we're going to leave it as the complete default just so that way everyone's on the same page. Now, the first thing you're going to do when you open up Mathematica is you're going to notice that your cursor is actually tilted to the side. And this bugs a lot of people out to begin with, but this is actually how you know that Mathematica has an empty line. What's an empty line? An empty line is effectively what I call a region of space where you are able to put in anything. So if you were to right click, you can see a couple options. One of them is Insert New Cell. And this is where you actually start doing all the fancy stuff you need to do. And you can see a whole bunch of little stuff in here. Most of the time, the only things you're really going to be worried about are text, code, and input. You don't need to worry about anything else because these are the three main blocks in Mathematica that you'll be using. For those of you that used Notion before, you're probably already very familiar with the idea of blocks. If you haven't, that's completely fine. Blocks is just a really fancy way of saying, this is what I have in this section. And there's a fly on that camera, so that's very cool. Hopefully it's not in the way, but we'll use that one instead for now. Anyway, first thing I'm going to do is I'm going to just get away from that. Right now, Mathematica is defaulting to the input section, which just means that if I put in something, it's considered an input. So let's just do a very simple calculation. 1 plus 1. We know this is equal to 2. How do I get Mathematica to actually calculate this? That's the step that a lot of people really struggle with. If you press enter, nothing happens. And you go, oh my God, this is terrible. What do I do? What am I supposed to do? I put enter into the thing. Every time I have any type of code, I hit enter and it runs, right? Mathematica doesn't do that. Mathematica thinks that when you put enter, you want to input another line of an input code. And it goes, oh, okay, well, you want more stuff to calculate. Don't worry, I got you. So it's actually being a little bit intelligent, which is not very helpful for people who don't know how to use this software. If you want to run an input line, if you want to run code in Mathematica, what you need to do is you need to press Shift and Enter both together. So just like how you would do like Control Z or Command Z on any other computer, right? Shift Enter. And then if it's your very, very first time running Mathematica or the very first instance of you running Mathematica, it might take a little bit of time to run. That's to be expected. What Mathematica is doing behind the scenes is actually booting up this thing called the kernel. And the kernel is kind of like Mathematica's brain. And Mathematica goes, ooh, okay, this guy wants to run a bunch of code, even though the code you're going to be running is very simple. And it goes, okay, I need to prepare myself, I need to warm up, and I need to boot up all the potential code lines and functions that this person might want to use. And so it warms up the first time you input a code in. And unfortunately, this means that most times it'll actually take a couple seconds to run a very simple command, no matter how simple it is. So if your 1 plus 1 takes a little bit of time, don't worry, your computer's not crashing out. You don't need to go out to the store and beg your parent or guardian to buy you a $20,000 computer. It's just taking its sweet time to boot up the kernel. Look, if you're watching my videos, that means you're serious about getting on top of your education. So the best thing you can do is sign up to our Mathematica workshop. Top link in the description. You should check it out if you haven't already. It's completely free. We go through problems live. We go through practice problems. We go through past exam style papers. And we go through tips and tricks to really help you get on top of this incredible tool. We also answer questions live, and I want to make sure that you are in there. So check it out, top link in the description. So we can see now that once we input 1 plus 1, we get an output of 2. Let's say that you're using Mathematica on a bigger monitor at home, or you have a bigger computer and this is really hard to see. One thing you can actually do is you can actually go to the top right where it says 100% most of the time, and you can change this to 150%. And you can see it gets a little bit bigger, and that's helpful. Cool. Okay, we got a bunch of stuff. Other things that you might notice in Mathematica is that it actually gives you a couple options on the bottom, which is kind of weird questions that Mathematica is asking. It's like number of primes less than 2, a binary form, range, perfect number. These are all options that Mathematica prompts you with in case you need them. So it knows, hey, when most people input in something like this, they actually tend to want to ask a couple of these questions. So they might want you to represent this in binary. And so it represents it to you in binary and it gives you the code that does it. Right? And so this is how Mathematica kind of allows you to do a whole bunch of stuff. So people who do binary might want to convert back into decimal form. And this is the normal numbers we're dealing with, right? So it does all these things for you, and it's actually incredibly helpful. Most CAS calculators can't do that. So this is actually one of the biggest advantages in Mathematica. It prompts you for things, and there's no way to really turn that off, as far as I'm aware. Maybe if you're very, very technologically capable and you can go into the Mathematica kernel systems and files, you might be able to do that. But for all intents and purposes, we're not going to do that because it's not really needed. Okay? So we've gone through and we've done our first code. 1 plus 1 is equal to 2. Fantastic. How do we interpret all this stuff? Well, you can see that Mathematica gives us IN1. That stands for input 1. And that is literally just, hey, this stuff is my input box, is input 1. And then it says OUT 1, out 1. This means that for the input you have, this is the output I'm giving you. And if I were to do a different calculation, let's say 4 times 15, and I press Shift Enter, Mathematica gives me input 6. Why is it not going up to input 2? Well, that's because I actually ran different inputs before. And Mathematica is keeping track of all of these things. And because it's keeping track of all of these things, it realizes, oh my goodness, I need to make sure that it's very clear and concise what the inputs and outputs actually are. So input 6, 4 times 15, output 6, 60. Mathematica is telling us, hey, for this line of code that you have, this is actually what the answer is, or this is actually what I'm supposed to spit out. So if you ever have graphs, and if you ever have really complex code and expressions that you want to run, it'll always output as input, the number, then output for the same number. So just keep that in mind, that's what the things on the side mean, okay? Now, let's say we didn't press Shift Enter and we still wanted to keep, adding in a whole bunch of stuff. Let's say 1 plus 1, and then I wanted to do 15 times 75, for example, and then I wanted to do 100 squared, okay? Actually, let's not do squared just yet because we haven't done squared. Let's just say 100 times 100, okay? I have 3 separate sections, basically. I have 1 plus 1, 15 times 75, and then 100 times 100. What is Mathematica going to do here? Have a think. So this is all in one input box. So do you think Mathematica is going to give you one single output box with all of these separated as different things, or is it just going to combine all of them together? What do you think Mathematica is going to do? Let's test it out. Input 7, output 7, output 8, output 9. Mathematica recognizes that these are all separate instances of code or separate instances of inputs. However, it doesn't tell you that because you put it all in the same line. Because you pressed Enter to go into a new line, Mathematica goes, oh, okay, they want us to separate the answers for this. They want us to separate the answers for this, so I'm going to make sure that I do that because this user has clearly said that they want a new line and therefore a new output line. And so your calculation, input 7 goes to input 2, output 8 corresponds to the next line, output 9 corresponds to the line after. This can be very annoying because if you're doing an exam or if you're doing a practice test of some kind or you're doing problems in class, you might see this and go, oh, input 7, and then think this is the only answer you have. And then you look back at your code, you scroll up a little bit and you try and find input 8 for output 8 and you can't find it. So I would say every single time you actually have new inputs that you want to put into Mathematica, new lines and stuff, you actually do separate it with new input lines rather than putting it in the same input box and then hitting Enter, just because it makes it a lot easier for you to determine what goes where. Anyway, let's delete all this stuff, make Mathematica a blank slate, and we start again. So these are all input boxes now. Let's say I get back to where my cursor is slanted. You can see my cursor being slanted, and I click in an empty space. You can see Mathematica gives us a cool little bar and it has this little plus sign. If you click this plus sign, it asks you what type of input you want. You can input Wolfram language, which is the default setting. You can input free input form, which I don't really suggest you do, to be honest. You can input Wolfram alpha query, which is something that you can send to the cloud, I'm pretty sure. Then you can ask for external language input, and this is all like Python and other types of code and stuff. We're not going to mess with this. It's not really too necessary, so I'm just going to delete that. In general, I actually don't suggest you input new cell types this way, just because it is a little bit annoying later on. What I would suggest you do is you always right-click and insert new cell and then pick one of these 3. That's just my general advice. You're welcome to do whatever you want to do. I don't really care because it's your software now, right? I just like doing it this way. That way I'm always certain that I'm inputting in the right things. So let's say I wanted to write some text. I wanted to say the answer is 7, for example. I input in a text cell and I type in the answer is 7. Fantastic, that's really, really helpful. Let's say that I wanted to do a similar input thing and I forget to do any of that cell type stuff. What happens to Mathematica? Well, if I just start typing away when it's not any type of cell specifically, I haven't specified the type of cell, Mathematica actually realizes and recognizes, oh my goodness, this person hasn't actually told me what type of cell it is. And it defaults to an input cell. That's the type of cell that Mathematica defaults to all the time. It defaults to an input cell because that's usually what you use Mathematica for. But if Mathematica recognizes that you're typing in an answer or you're typing in text, it actually gives you the option to convert it into a text cell later, which I think is very handy. So just keep that in mind, that if you ever forget, you can just change it like that. Now let's say that I change my mind and I want this to be like 7 plus 2. Then I press Shift Enter. Uh-oh, nothing happened. What went wrong? Well, this is still a text cell. It's not an input cell. Mathematica doesn't recognize that you want to actually put in code and run things. So this is just a text cell. Mathematica doesn't touch text cells. It doesn't run code on text cells. So how can we convert this into an input cell? How can we convert this into something that Mathematica can actually run? Well, the easiest way to do it is just to copy and paste into a new cell, input, paste it in, Shift Enter. The reason I want you to do this instead is because it allows you for more control, just in case you want to keep that text cell for whatever reason. Okay, let's say that you're writing your answer in and you really don't want to mess around with things, you can just input it in like that. So copy paste it in just like a normal copy pastable thing and you should be a-okay. Now, we've gone through a couple of very simple operations in Mathematica, and we've actually gone through a couple of very straightforward levels of understanding on how this system works. What I want you to do is I want you to really understand all this stuff, because again, just like I said at the start, a lot of students don't really understand what's going on in Mathematica and they just think, oh, I'll figure it out. No, this is not something that you can just figure out. You really need to put in the work in Mathematica. You need to be able to actually sit with Mathematica for a while. And if you're able to do that for the next 2 to 3 months, you will be in a much better position than most of the people who are just going to wing Mathematica. I know there are so many year 11 method students who are doing 3-4 that still don't know how to use this software. And they're going to these, giant companies and they hope and pray that they'll end up with a great study score. That's not going to work out for you, okay? If you're anything like what I was back in the day, you really need to sit down and learn how to use this thing. Because trust me, this is an incredible, incredible tool. Now, what I'm going to do is I'm going to actually just pull up something from our Clarity Coaching workshop, or planned workshop anyway. And again, if you want to join the workshop where we go through live how to use Mathematica and go through practice problems as well as understanding and answering questions on how to use this tool, top link in the description is completely free. So I'm not going to charge you anything for it. It's completely free. I just want to make sure that you know how to use this tool because it's genuinely incredible. So top link in the description. Check it out. All right, so I'm just going to copy paste that table in here. I'm going to press Shift Enter so that way it looks a little bit prettier. And I'm going to delete this guy so that way we don't have to deal with it too often, okay? So here's what the general idea of Mathematica kind of looks like, okay? So the typical plus symbol in mathematics is represented by the typical plus symbol in Mathematica. So no difference in that. Same thing for the subtract symbol, it's still the subtraction symbol. The multiply symbol is represented by the asterisk symbol. And if you're not sure what the hell the asterisk or star symbol is, you just need to press Shift and 8 on your keyboard if you have a standard keyboard, and it'll give you a little star. I'll go through an example right now. 3 times 2. I press Shift 8, press Shift Enter, and then you're A-okay. If you try and do 3x2 like this, it's not going to work out too well for you. If you're a little bit more advanced and you're already familiar with Mathematica and you want to kind of shortcut your way through things, what you can actually do is you can press space. And Mathematica gives you this cross operator, which looks very much like a multiply, but it's actually a cross multiplier. And it allows you to do this calculation relatively quickly. Okay, so you can just use space as well. I wouldn't recommend doing that just because it can get a little bit finicky. But if you're very comfortable with Mathematica and if you've done Mathematica for a while, you might want to transition into the space to get the invisible multiply is what I call it. Anyway, let's talk about divide now. Typical division is represented with a line and 2 dots. However, in Mathematica, that is just represented with a slash symbol. And the key thing here is the forward slash, not the backslash. So if I were to do 6 divided by 2, I need to do that forward slash. And you can see Mathematica for a second actually gives you a pink operation. And you can see this for pretty much every single type of inbuilt mathematical operation that you have, right? So if I were to do subtract, it'll give me a pink symbol. If I were to do plus, it'll give me a pink symbol. Multiply, it'll give me a pink symbol. This tells you, hey, Mathematics is getting ready for you to actually start doing proper calculations. And it knows, this is an operation I need to do. So it knows that. So it's always important that you have that pink symbol there. If I were to do slash, it doesn't work. Okay, so slash is a completely different tool in Mathematica. We won't cover it too much in depth in here, but we'll talk about it more in the workshop. Again, I know I'm plugging the workshop a lot, but that's just because genuinely I believe that this workshop will help you so much when it comes to understanding this incredible tool. So how do we do divide? /. So do that, shift enter, and you get cool little numbers like this. Okay, and these are the key things. Now, powers are a little bit weird, and this is where we're going to start talking about symbolic tools, is what I call them. I don't know what the proper name is, and I don't really care, but I call them symbolic representations of mathematics. Basically, you know, when you write a square root or a power, you don't just do like a little arrow or a little hat and then put the power, right? That's what Mathematica wants. Shift 6, 3 squared gives us 9, right? That's how Mathematica does things. If you don't want to have this really ugly looking thing, what can you do? Well, Mathematica is really powerful. What you can actually do is you can press 3, Control 6. That's the Mac command. I think for Windows, it might be Alt. I'm not sure. It might be Control, it might be Alt. I'm not too sure. You're gonna have to test it out. I'm pretty sure it's Alt though. I can't remember. It's been a while since I used the Windows on Mathematica. But it's one of those symbols, okay? Then you can put the square in, and then you're A-okay. Notice how Mathematica gives you this weird little box thing. It's like this weird little gray box, and it defaults your cursor over it. This represents the operation of powers. And Mathematica uses this little box to represent, hey, you can put inputs into this guy. You can put numbers into this guy. You can put expressions into this guy. You can put a whole bunch of stuff into this dude, and he's going to be able to do all the stuff you needed to do. So in this case, if I wanted to do 4 cubed, shift enter, 64. And this is really, really handy. You can do the same thing with fractions. If you want to do 3 divided by 7, you can input that in. And again, Alt divide symbol, or Alt slash or Control slash on Mac, right? I'm not sure if it's Alt. Someone correct me in the comments, please. It's one of the Control, one of the Alts, one of the bottom buttons. I'll probably Google it later and realize, oh yeah, that was that. I used Mathematica on Windows for a very long time. I just can't remember it now because it's been literally years. But you can do this. Now, we're expecting this to be some type of decimal. Mathematica doesn't give us a decimal. Mathematica leaves them as exact values. And this is in general how Mathematica treats numbers. If you input in exact values, Mathematica will give you exact values. It won't convert to decimals. However, there's a couple tricks you can do to make sure that Mathematica always converts into decimals and doesn't deal with fractions. The first thing you can do is you can actually put 3.0. And when you do that, Mathematica goes, I see. Okay, so you actually want these fractional things to be in decimal form because you put a 0.0, right? 3.0 and 3 are the exact same thing, but Mathematica goes, I see. You want this to be a decimal. Cool. That's kind of annoying to keep in mind, and it's very annoying to do. So what you can actually do is you can actually do something a little bit cheeky, is //N. //N is something called numeric form. This is a shortcut in Mathematica. Birdies, I don't know if you guys saw the birds, but you know, we're outside, incredible weather. It's very warm actually, but the wind's nice. So, you know, who needs a studio when you have the outdoors, right? So the //N is the numeric form of pretty much every single thing. You can get numerical calculations in Mathematica using this thing. If you don't want to do that, you don't want to do //N to get the decimal format, what you can actually do instead is you can do capital N, square bracket, the number that you want, the decimal form, shift enter, and that gives you the same thing. So this is just a shortcut. You can do this for very certain commands in Mathematica, and it allows you to do it. I always just do //N right at the end. I don't like doing this thing in here, just because I just find it a little bit annoying. And this brings us to the next thing in Mathematica that we need to be very, very aware of, which is how to use its inbuilt functions. Now, inbuilt functions are very annoying because inbuilt functions have very specific syntax. And this is where you really need to make sure you understand how the tools are used. Let's start with the typical solve command. Let's say I wanted Mathematica to start solving equations, solving systems of equations. How do I do that? Well, on a typical CAS calculator, you type solve, put in the brackets, 3x is equal to 8, comma x, and then you press shift enter or enter, and then you're done, and it spits out the answers. You can see that Mathematica is treating all these like a variable. That's what this blue text means. Mathematica is saying solve is a variable, and that's not helpful. So how can we actually get the solve function, the solve inbuilt Mathematica tool? Well, it's actually really easy. We just need to capitalize things. So just like in English, how we capitalize the start of our first letter, Mathematica does the same thing for its functions. Capital S for solve. And you can see it goes from blue to black. That's really helpful for us. Blue to black. The next thing we want to do is we actually want to remove these curved brackets that we usually use, these parentheses that we usually use, which is shift 9, shift 0. And we want to change it into square brackets. And you can see these square brackets start pink. Dogs are barking, fantastic. But these square brackets go pink and then they go black. And if you press shift enter just like this, Mathematica is going to give you a couple errors. Don't worry, this is completely expected. So don't worry when you get errors. It says tag times in 3x is protected. Okay, don't know what that means, that's fine. 8 is not a quantified system of equations and inequalities. Don't know what that means either. We can kind of ignore this first one because this is just saying some random stuff. This is the real error that we need to deal with. Okay, so this is saying that, hey, 8 isn't a quantified system of equations. In other words, this is not actually a system of equations Mathematica can solve. Why is this the case? Well, Mathematica uses a single equal sign to assign values to something. This is defining values. So if I were to say, for example, a is equal to 7, and then I wanted to do a plus 3 later, press shift enter, it'll give me 10. Single equals assigns values, it defines values. Mathematica will remember this for the rest of the time. Okay. So when we do something like this, we're telling Mathematica, hey, I want you to solve this system of equations, but I'm defining it like this. And Mathematica goes, what do you mean? This doesn't make any sense. I don't understand. Because you want me to solve, but you also want me to define something at the same time that doesn't make sense to me. So how do we fix this? The easiest thing we can do is actually just put in another equal sign. And Mathematica knows when you do a double equals, this is asking you to not actually assign any values, but it wants you to represent an algebraic equals and things like that. So now if you press shift enter, you'll get the answer 8 on 3. Fantastic. However, Mathematica does it in a very weird way. Again, keep in mind, equal sign means define and assign. So Mathematica doesn't give you an equals when it gives you the answer. It says x arrow 8 on 3. And it does it in this very weird parentheses notation. This is really, really helpful for later on stuff. You can actually do a bunch of shortcuts with this, which we'll go into again in our live workshop. And this is a very useful tool to use to actually shorten the amount of code that you need for any type of question. So solve 3x double equals 8 gives us 8 on 3. And gives you the answer. Let's say we wanted this in a decimal format. Easiest way to do this is // capital N, because again, capital represents actual Mathematica functions, right? Shift enter. Now we get 2.6 recurring, which is the final answer that we wanted, right? So right now we've gone through how to create a solve system in Mathematica. We've gone through how to understand what is happening and stuff like that. Let's say I had a simultaneous equation to solve. How do I represent simultaneous equations? This is where the tricky part comes in, because a lot of people get really, really confused. Now, let's actually break down what's happening in this line before we keep going. We're telling Mathematica, hey, I want you to solve this thing. Then we're telling Mathematica, this is the equation I want you to solve. Okay, cool. Then we put a comma to tell, oh, by the way, this is the variable I want you to solve for. So we have the solve command, we have the solve expression, and then we also have the variable we want to solve for. When we press shift enter, it gives us the answer for the expression. So let's now convert this into a simultaneous system. If we just type in solve, and we want to include in another thing, let's say we want to include in another random equation, 2x plus 4 double equals 9, or 5 double equals 9, sorry. And again, I want them to solve for, let's say 5y and 3x plus y, for example, and I want them to solve for x and y, right? You would think Mathematica actually knows exactly what I want. That's what you'd think. That's not what happens at all. If you were to press Shift Enter on this, Mathematics is going to give you a whole bunch of confused jargon, and it's not really going to make too much sense. What's actually happening here? Well, if we look back here, the thing before the comma is the expression we want to solve for. The thing after the comma is the variable we want to solve for. That's how Mathematica defines the solve command. It always does. Thing before comma is the expression. Thing after comma is the variable we want to solve for. So there's no way that Mathematica will be able to know, oh, this is the expression you solve for, and then the variable is all just gobbledygook. No way it can know that. This stuff is basically not even considered in Mathematica. So how can we tell Mathematica, oh, this is just my sequence of expressions? How can we do that? Well, it's actually really simple. We need to input in more brackets. Not just your typical parentheses. No. We need to input in curly brackets. You can get this by doing Shift closed square brackets. We go right before the first proper comma, and then we tell Mathematica, hey, cool. This is actually all the equations I want you to solve for. And this is the variables I want to solve for. What have we just done? We've given Mathematica a list of inputs. That's what this curly bracket does. It gives you a list of inputs. So Mathematica goes, oh, got you, dude. You want me to take this sequence of equations and treat them like a list. So this is equation 1, that's equation 2. You can have hundreds of equations in here. I know exactly what you want because this is just a sequence of list stuff. Gotcha. And this is telling me these are all my variables I need to care about. I understand now. Now if you press Shift Enter, Mathematica got you covered. Super annoying, I know. But trust me, there's a reason why this is here. This is very helpful. This is very powerful. And again, you'll notice Mathematica does the weird thing where it tells you X and then tells you the arrow, Y tells you the arrow. Okay. Now, this would be the part where I ask you if there are any questions, and you tell me, but obviously I can't do this through a YouTube video. So sign up to our workshop where when I ask if you have any questions, you can actually let me know if there are any questions. Now, congratulations, you've actually typed in your very first Mathematica command. So let's actually break this down a little bit more. I'm going to zoom in a little bit more on this, and I'm going to go through a couple more things. So let's say we want to solve for another system of equation. Let's say we wanted to solve for 2x plus y double equals 10, and then y plus x double equals 4. Let's say I want to solve for that. How do I represent this in Mathematica? Okay, Vihanga, I know that I want you to do a solve. Cool. Square bracket to begin with. Mathematica usually fills in the square bracket if it's aware that this is just a typical instance of code, but sometimes it won't do that, so just keep that in mind. If it's green, you know you're A-okay to keep writing stuff in. And hey, Vihanga, you have 2 equations in here, so I know I need to separate this as a list of things. Great, you're doing great. Curly bracket, input in our values. 2x plus y, double equals, because if I do a single equals, it's going to give me a define and a sign. 10, comma, to separate my equations. Y plus x, double equals 4. I'm not done here. I need to tell Mathematica what variables I want it to solve for. So comma, curly bracket again, because I have 2 variables, right? So I need to list again. You're doing great. X, comma, Y. Separate them out. Shift Enter. Huzzah, we get answers. This should be very much like an ingrained skill when you do mathematics stuff. You should be like off the top of the dome. You should be able to write this stuff out. Trust me, this is a really helpful tool. It's much quicker to write this stuff out than it is to just copy paste random bits of code and then hope that the text file works and stuff. It's so much easier just to write it out. Trust me. I know I sound like a psychopath saying that, but it is so much quicker. You understand it a lot better, and it's just easier to do overall. So you've done your first set of code. Fantastic. Now, let's say I wanted to use the variable a instead. I wanted to say, okay, well, I want you to solve for 2a plus 7 double equals 10. Comma a. Tell Mathematica I want to solve for a. I don't know what's going on, Vihanga. This is scary. I don't know what's happening. This doesn't make any sense. Why is it wrong? Well, if you remember before, I assigned a to a value. So when I did that, Mathematica remembers. It's better than you and me. It remembers a lot of stuff. Mathematica remembers this. And it goes, hey, wait a minute. You want me to solve for A, but you told me what A was before, and now this system doesn't really make sense because this isn't true. And even if it was true, it still wouldn't make sense because you've already told me what A was. So what the hell, man? What do you want me to do? Mathematica remembers A is assigned, and so it won't touch it. Almost every time, this is the number one error I see in students, as well as a couple other things that I'll go through in the workshop. But this is a very big issue that people have. And so, how do we fix this? Well, it's really easy. You just need to tell Mathematica to forget. You need to wipe its memory. And that sounds very, dystopian, but it's actually really easy to do on this. So we're going to type in a clear command, and we're going to tell it to clear A, shift enter. And this tells Mathematica, hey, I want you to forget whatever I told you about A. Now, if we go back into this code, shift enter, it's A-okay to do. Number one issue I see in all these lines of code that students have. Not being able to clear their variables properly. Anyway, this should be good enough to get you started with Mathematica. We haven't gone through any of the more advanced stuff, but again, I'm leaving that to my workshops because it's way too much for a YouTube video right now, and I don't think I'll be able to do enough justice because trust me when I say a lot of students have so many questions and issues when it comes to Mathematica and understanding how to use Mathematica. If you're interested in joining our workshops and getting much more hands-on experience and going through past papers and practice problems with Mathematica, top link in the description, join our workshop. Okay, so we've just gone through a couple of understandings on the CAS, not the CAS Mathematica, goodness gracious. So we've just gone through some understanding on Mathematica, we've gone through some practice in writing the systems. Let's actually go through a practice problem together. So right now, we have a situation where we have Timmy and Sophie, and they're saving money. Timmy has only $5 notes and $10 notes in his wallet. Altogether, he has 18 notes worth $125. Write a pair of simultaneous equations to model the situation. Solve the simultaneous equations and state your final answer. Okay, cool. Let me put a full stop in here because that actually is bugging me a little bit. Okay, how do we go about solving this if this was a practice problem in a test or a practice test or an exam? How do we actually do this? Well, when we're writing our code, we need to make sure that the examiner and assessor understands what we're doing and how we're doing it. So the best piece of advice I can give you is to just walk them through your code very plainly. So to begin with, I would say let F, converted to a text cell, equal the number of $5 notes. Okay. And then I would say let T equal the number of $10 notes. Super, super easy, right? Then I would identify what the price is for my notes. So I would then create a new line and I'd say, okay, well, if I have $5 notes and $10 notes, depending on how much there's some number of $5 notes, some number of $10 notes, right? So the first sequence of equation would be, first equation is F plus 10 is equal to 18, because we have 18 notes in total, okay? First equation is number of notes, which is F plus 10 is equal to 18. If you wanted to, you can actually write this really fancy in like code format and stuff like that. Oh, sorry, not 10, it should be F plus T, because T is the representation of notes. Sorry, I messed that up. I misspoke. I thought in my head like T, and then I said 10 and then I wrote 10. So my bad, it should be F plus T, because it's variables, right? So this is our first equation. Cool. The second equation is the total cost of notes, or total price of notes, which is 5 times F added with 10 times T. So if I have two $5 notes, that's $10 worth, right? So 2 times 5, multiply the price out. This is all equal to 125 apparently. Right, this is a very stock standard simultaneous equation. I'm sure you're okay with this. If you're not, then you definitely want to make sure that you're on top of simultaneous equations. Have a crack at your past problems in your textbook and stuff like that, or your worksheets and stuff from school. But this is our two systems of equations. Okay, so this is the pair of simultaneous equations to model the system, to model the situation. Cool. So therefore, the two, oh, sorry, I need to write this as a text cell, not whatever this is. So let me delete that real quick. Insert new cell, text cell. The first, equation 1, is f plus t is equal to 18. Equation 2 is 5f plus 10t is equal to 125. Okay, and this is how I would write my systems equation. This is very annoying, but most of the exams you'll do will actually be on Mathematica. So you need to make sure you understand how to represent all this stuff in Mathematica, because if you don't, you're in a lot of trouble. So get used to doing this type of stuff. So that's part A done. Fantastic. We can even write this as part A. Okay. And you can do that. So this is a Mathematica shortcut we can use to basically put a comment in kind of fancy-ish notes and stuff. So you can just say part A, and then that implies to the examiner, oh, this is part A of the equation. Cool. We do the same thing, part B, and do the next part. So the next half is actually solving the system's equations and stating our final answer. So all we do is we put a solve in, we do f plus t double equals 18, that's our first equation. The next one will be 5 times f added with 10 times t double equals 125. Then we need to make sure that we understand, hey, we're dealing with f, we're dealing with t, that's the variables we need to solve for. Shift, enter. Mathematica gives us our answer. Cool. We don't end the question like this. We can't end the question like this. If you've ever had a math teacher like I've had math teachers, they would tell you, what do I have? 11 oranges, bananas, coconuts, people? What do I have? So you need to state your final answer. And it even says in the question, state your final answer. So we would need to state it as text. Hence, 11 $5 notes and 7 $10 notes. And that's our final answer, because that's what Mathematica told us. Again, if this was helpful to you and you want to know more in Mathematica, you want to know how to plot, you want to know how to plot quickly, you want to know how to manipulate and get sliders and all that really fancy stuff that's really, really helpful in your final exams, then you definitely want to check out our workshop. It doesn't matter if you've never used Mathematica before, you've used it for a year, whether you're in year 10 math or 1-2 methods or 3-4 methods, this workshop is meant for anyone who has little to no experience with Mathematica to get really up to scratch and put their best foot forward for their first exams and practice tests. So sign up, top link in the description. I know I've been plugging this a lot, but I really, really want you to come in because we're going to do so much stuff in Mathematica and you definitely want to be there for it. Anyway, it's good to be back. More videos coming soon. Thank you for watching. You know the drill. Don't like, don't comment, don't sub. Log off and do something else now. See ya.